Hey there, fourth grade. We're going to talk about area and perimeter some more today. Today we're going to talk about finding the area and perimeter of compound figures. Starting today. Today we're going to do all the side lengths being given. In the future there will be a day when some of the side lengths are missing. Those can be a little trickier. Starting here. Compound figures, if you want to add to your title, sometimes they're also called composite figures. If you want to make note of that word too. We'll talk about what that word means in Connect, compound or composite. So go ahead and make this the title of your next page and then unpause when you're ready. Give me your total concentration till we get to we do. Okay. So real quick review. We've been talking about area and perimeter. We talked about tiling. So like if this was 2 inches, we would partition it in 2. If this was 10, we'd partition in 10. And we also had formulas, which I'm going to use again today for area and perimeter. Since how the tiling worked, the area formula was length times width, because I'd end up with 2 rows of 10 or 10 rows of 2. And the perimeter formulas we've talked about were either length plus width plus length plus width, or since that works out to where you're doing the length twice and the width twice. We also talked about doing like 2 times the length plus 2 times the width for the formulas. This idea of compound or composite figures that we're going to start today are ones like this. Compound, you probably know like compound word, that's like cannot, where there's 2 words put together. A compound figure is like 2 rectangular figures put together. So it might be, something that looks like this is what we're going to find area and perimeter of today, where it's like you could think of it as being 2 different rectangular figures, a compound figure. We're going to work on those. So speaking of, let's do one. Here you go. Let's find the area and the perimeter of this thing. Okay. So if you'll notice, we've got this figure. It's got 1, 2, 3, 4, 5, 6, 7, 8 sides. Actually, I need to give you one more that should be written on there. Sorry, this should also be 7 feet. And so all the sides but one are given to you. This one's not given, but it really kind of is. Before we do our formulas, we need to make sure we know how long that side is. But as you can see, it's the same length as this side, so sometimes they won't label it because it works like that, but it's the same length as that side. So I'm just going to go ahead and mark that. It's the same here, 12 feet. Only because I can look and I can tell that they're the same. This one you couldn't do that with because there's nothing to compare it to. Looks like it might be the same length as this, but I don't like to do that unless they're like line up. So I was supposed to just give you that one. So there you go. So the perimeter, to find that, if we're going to do both. Remember, perimeter is the distance around, so really all I'm going to do is just add all of these sides up. Easy enough, right? I'm just going to measure the distance all the way in. So I'm going to pick a starting point. I'm going to start, I like to do, if there's like a really long side, I usually like to do it first, so there's no reason you have to. So I'm going to start here and go around. I just got to make sure I get every side. So it's like 34 plus 8 plus 7 plus 12 plus 20 plus 12 plus 7 plus 8. And that many feet is the distance around. So let's see, 34, 42, 49, 51, 61, 71, 81, 83, 93, 100, 108, it looks like to me. I did that really fast if you want to double check my math. But it's 108 inches around, not square inches. Remember, area is measured in square units because we tile it in squares on the inside. But perimeter is just how far it is, just any other regular length unit. All right, to find the area of this thing, I don't remember, my length times width formula works for rectangles because I can tile them. So I can't just look at this and say the area is the length times the width, because what's the length? Is this the length? Or is this the length? But if that's the length, then I would have a rectangle like this, and I would have this extra area that I don't need. and it just doesn't work out that way. So I can't just apply this formula to this figure yet. I am going to use this formula because it's so quick and handy. But what I've got to do, this is only for rectangles. So what I'm going to do is I'm just going to split this into rectangles. Like if I were to do this and make 2 rectangles, now I can do the formula here for this top rectangle, and I can do the formula here for this bottom rectangle. Oh, it's not area times length, excuse me, equals length times width. All right, so if I split it into rectangles, now I can apply the formula. So this rectangle has a length of 20 and a width of 12. And this rectangle has a length of 34 and a width of 8. So I'm just going to find 2 separate rectangles and add them together. So I'm going to do the top is 20 times 12, which is, let's see, 10 times 12 would be 120. So 20 times 12 would be twice as much. That's 240 square feet. If I were to do 20 here, 12 here, I'd get 240. And then the bottom has an area of 34 times 8. I don't think I can do that with a number talk strategy like I just did the other one. So I'm just going to have to do 8 times 34. That's 240. 8 times 4 is 32. 240 plus 32 is 272. So that's the bottom, square feet. And now, so the area of the whole thing is just this plus this. It's 240 plus 272, which is 211, 5. So the whole thing would have an area of 512 square feet. All right, so that's the strategy. So perimeter, we just count our way around the outside. For area, we're usually going to try to divide it into rectangles and then find the area of each rectangle. And that's pretty much how it works. Okay, so let's do one together. Open up your notebook, and we're going to do this one right here. Gotta move it down. Make sure you note the distances as well as the figure. So we're going to do this 2 ways. So we'll first find the perimeter. That is the distance around the outside. And really, you know, all you're going to do, pick a starting point. I often like to just do the longest one first. And it's just going to be all the way around. It's just going to go 10 plus 9 plus 4 plus 7 plus 6 plus 2. And just count it up. That is 19, 23, 30, 36, 38. And remember, perimeter is just in regular units, 38 centimeters around, not square centimeters. That's for area, because area you make squares on the inside. We're not doing that with perimeter. We're just literally measuring it like a ruler. Ruler, 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 ruler. And rulers measure in regular centimeters, not square centimeters. So that's the perimeter. Area, if you'll look, it's even already been done for us. Someone's divided this in 2. Also could have ignored that. Most of the time with rectangular figures, there's more than one way you could do it. And we could just kind of not divide it here and instead divide it here. And we would get the same thing if we did a rectangle here and a rectangle here. Wouldn't matter. But we'll go ahead and just do what they did. Go with the flow. So here we're going to have to find the area of the top and the area of the bottom. We're going to use the formula 2 times and add them together. So it's like the top plus the bottom is going to make the total area. And we're going to do length times width to find this one. And we're going to do length times width to find this one. So the top one, area equals length times width. The length is, the length is either, you've got to watch out here. This 9 is for this whole side, not for the top one, right? So the length and the width here are 7 and 4, not the 9. The 9's for this whole big side. So you've got to be a little careful when choosing your length and width. Not really choosing, identifying. So it's going to be 4 times 7, which is 28 square centimeters for the top. And then we're going to add to that the bottom. The bottom is a 10 by 2. Again, not the 9. The 9 is over here. This rectangle is a 2 by 10 rectangle. So area equals length times width, which is 2 times 10, which is 20 square centimeters. And there you go. Add my top area and my bottom area, and the whole thing is 48 square centimeters. Okay? If you want to make a note, the big key is don't just try to do length times width for the whole thing. Because if you do that, you're doing the length of the whole thing is 10, the width of the whole thing is 9, and that's how you would find a figure that looked like this whole big rectangle, but that would include all this extra area that's not in your figure. So you can't just look at a compound figure and use the formula for a rectangle. All right. So hopefully that is not too bad and makes some good sense. Tomorrow we're going to keep doing this, but some sides are going to be missing. They're not going to be giving you the length of all the sides, and we're going to have to figure them out before we do this same process is how that's going to work. So hopefully this made a lot of sense. Go back and look at the examples again if you found this confusing, or if you got distracted, or if you in any way weren't able to apply your whole concentration. But once you feel good enough to come to class and talk about this more tomorrow, you're all set, and I'll see you then.